Alright, let's do another problem set on derivatives. And here in the first part, in problem 1, let's just review again how you actually do take derivatives. So here we have a function y as a function of x equals 5. So if we draw that, this would simply be a function where we have here x and here y, but the function is always 5, so it's a horizontal line. It's always 5. And you know that the first derivative is the slope. So the slope here, at any point, you know, it's always 0. It doesn't go up or down. So in this case, whenever you have a constant, the first derivative of a constant is always 0. Okay, so now we have another function, w of x. So this function is called w. And that is a function where we have here w. And so at 1, this would be 5, and at 2, this would be 10, and in 3, that would be 15. Okay, so this function would look something like this. So it's pretty much a straight line, something like that. But you can see whenever you go 1 to the right, plus 1, you go up 5. So because the slope is the rise over run, the change in w, which would be 5 if you go 1 to the right, and if you go 1 to the right, that would be dx, and the 5 up, that would be the dw. So in this case, the first derivative, because it's the slope, you know, at this point the slope is always 5, at this point is always 5, so at every point it is 5. So in this case, the first derivative of 5 times x is 5. Well, formally, you know, you can write the function wx equals 5 times x, and technically there is an invisible 1 up there. And then you still remember what is the rule. So if you take the derivative dw with respect to dx, step 1, you take the exponent of the x, that goes in front. So now we have 1 times 5 times x raised to the 1. Step 2, we have to subtract now 1 from the derivative, minus 1. And then we get 1 times 5 times 5. That's 5 times x to the 0. And something raised to the 0 is 1, so we get 5, which is this result. But the point is that on every point on that straight line, the slope is obviously 5. Okay, so now we have another function. Okay, let's take this one, z of x. So actually, let's do it this way here. So that would be a parabol. So we have here positive x, and here we have z. Well, that is a function that looks something like this. So we have here a minimum. Well, I don't know why that's not giving a parabol. Let's try it again. Okay, something like this. And you see that there is obviously a minimum. There's a point where the slope is 0, but then at positive x, the slope becomes steeper and steeper and steeper. So as opposed to the first two examples where we always get a constant, for the derivative, this here must be a function. And for positive x, the slope becomes steeper and steeper and steeper. Okay, so how do we take the derivative? So we do again our regular. So first step, that goes in front. And then we have 2 times 5 times x squared. And then step 2 minus 1. And then we get 2x. 2 times 5x, which is 10x, which is the result, because this one here becomes 2 minus 1. So that would mean, for example, the slope at the value of 1 would be here, that slope. So that slope here at the value of 1 would correspond to a slope of positive 10. Likewise, at negative 1, here, you see the slope goes down, it would be negative 10. Okay, so now I think we can go a little bit faster. I think the idea is now clear. And so here we have a function which is y equals, f of x equals 5x raised to the negative 1. Okay, so this could also be written as 5 over x. But for the derivative, it's better to stick with this one because we see the exponent here. So again, step 1, that goes in front. So we have negative 1 times 5 times x minus 1 is minus 2, and then the derivative okay, so then the derivative would be so it looks like that would be now negative 1 times 5, that's negative 5 over x squared. Sorry. Okay, next one. So here we have g of x. Okay, step 1, that goes in front. So now we have negative 2 times 1/2 times x raised to the negative 2 minus 1, so that becomes negative 3, equals, okay, so this negative 2 cancels out with the 2, and then we are left with negative 1, and then we get negative 1 over x cubed. Okay, next one, h of x. Again, step 1, exponent goes in front, so we have 1 over 2 times 2 times x. Now we get negative 1/2. Okay, so the 2 cancels out with this 2, and then we get x to the negative 1/2. That is, as you know, 1 over x to the 1/2, or more conveniently written 1 over the square root of x. Okay, yeah, that's just a duplication. Y of x equals 5. That is 0. We know that already. Next one, j of x. Okay, so this is new. You haven't seen the log of x, but the log of something is also sometimes used to represent the utility function. It also looks like this. And if you take the log of x, the derivative of the log of x with respect to x is simply 1 over x. It's often convenient. I don't think you will see that in my course anymore, but maybe later you will see it. So it's good to note that the derivative of the log, the slope, is given by 1 over x. It can be often very convenient. So the first term is 1 over x, and then we already know 3 times x. If we take the derivative with respect to this term, we just get 3. Okay, then we have k of x. So the derivative, the 2 goes in front, so now we have here 2 times 1 over 2 times x, because 2 minus 1 is 1. Okay, next term plus, okay, this term, the second term, can be written as, okay, let's just write it again more conveniently so that the derivative becomes easier, plus 1 over 2 times x to the negative 2. So, okay, so now we do plus the second term, so the minus 2 goes in front, so we have here a minus 2 times 1/2 times x to the negative 3. Okay, so now this 2 cancels out with this 2. Here we get the negative, but this cancels out, but we keep the negative 1. So now we get simply x minus 1 over x cubed. Okay, now the last one, and then I'll stop there, and then we can do a couple of problem sets. So we have here m of x. Again, negative 2 goes in front. So we have negative 2 times 1 over 2 times x to the negative 3, negative 2 minus 1. Okay, this term, let's just write it again a little bit more conveniently. Okay, this x minus 2 would be actually underneath in the denominator. That would be 1 over x squared. But then it just becomes 1/2 x to the negative 2 plus 1/2 x squared. Okay, so plus, then the 2 goes in front, 2 times 1/2 times x 2 minus 1, which is just 1. Okay, so now some things cancel out again, negative 2 with the 2, so that gives us negative, so this cancels out, but we got to keep the negative 1, so that becomes 1, negative 1 over x cubed plus, again here, that cancels out, plus x. Okay, so the last ones were a little bit more complicated, but it's good to get a feeling for how it works. And they don't have necessarily economic applications, but you know, just for practice purposes, I hope that helped. And in the next video, we'll just do a couple of an example for how to use derivatives in economics. But I'll just stop here.